All right, this is still Pre-Calculus A, Unit 2, Lesson, is it 4? Yeah, inverse functions. I wanted to deal specifically with the domain restrictions and one-to-one functions. You recall the idea that if I take a function, like I'm just going to sketch here, y equals x squared, for example, and I reflect it across the line y equals x, I'm going to get a parabola that opens to the right, right? And the problem with that is that is not a function. It fails the vertical line test in that the function, the graph has two values with the same input value. Okay? And so we require, in order for us to find an inverse function, we require a function to be one-to-one. One-to-one. And in the case of y equals x squared and all quadratic polynomials or polygons, they're going to fail the vertical line test because they're a horizontal line test. So they're going to fail their inverses are going to fail the vertical line test. So a good test for one-to-one functions is that it passes both the horizontal and vertical line test. Every unique input has a unique output, horizontal and vertical line test. Okay? And really what that means is once a function starts in the upward path, it must continue in the upward path. It cannot ever go down because then it would fail the horizontal line test. Same thing in the other direction. If a function starts in the downward direction, it must continue in the downward direction. It cannot double back and go up, or it would fail the horizontal line test. All right? So that's kind of what one-to-one means. Every unique input has a unique output. But let's look at, I'm just going to bring up Desmos here. And we're going to look at the case of y equals x squared. In fact, I'm just going to do something a little different here. I'm going to say y equals, and I'm going to say 1/2. I'm going to say x minus 3 squared, and then plus 4. Okay? All right, so we have a parabola. It's been squished a little bit. It's half as tall. And its vertex is at 3 to the right and 4 up. You get that from transformations on polynomials. Okay? And if we try to find the inverse function, here's what happens. All right? We have y equals, let's change colors here, y equals 1/2 x minus 3 squared plus 4. I'm going to use the traditional approach. You could build it intuitively. I can build it right now intuitively. I take x, I subtract 4, I multiply 2, I square root, and then I add 3, right? And we'll verify. I'll leave that there. But let's switch x and y, 1/2. Y minus 3 squared plus 4. Start by subtracting 4 from both sides. Then multiply 2 on both sides. And here's the step that is kind of tricky. We square root both sides. Okay? And here's the part that is a problem. When you take the square root of both sides of an equation, okay, when you take the square root of both sides of an equation, there are actually two solutions. So let's say I had the equation x squared equals 9, and I square root both sides. We would get x equals 3, which is true, but there's something missing. What about x equals negative 3? Because negative 3 squared is also positive 9. And so we learned that when we square root both sides, we're technically supposed to have a positive and a negative root. And here's where the trouble occurs. So we have a positive root or a negative root. Now when I add 3, I get y equals 3 plus or minus square root 2 times x minus 4. Okay, that's actually two separate functions. Let me show you what it does on the graph here. Okay, so on the graph, if I enter y equals 3 minus square root 2 times x minus 4, we get half of a parabola. And if I get y equals 3 plus square root 2 times x minus 4, we get the other half of the parabola, except that I was supposed to have a 3 there. There we go. Okay, and always graph it with y equals x to verify that we do have inverses. But the problem is that the purple and the black together do not represent a function because they fail the vertical line test. And so what we do is we place domain restrictions on the green. So let's say I do this. Let's say I say I'm going to limit x to being greater than or equal to 3. That would limit me to the right-hand side of the parabola. And so if I look at the mirror image, the black function then is the mirror image, and I'm going to eliminate the purple, right? So the inverse function of the green is 3 plus square root 2 times x minus 4. But what if I said x minus x is less than or equal to 3? Then I would be looking at the left-hand side of the function, and I'd be looking at the 3 minus square root 2x plus x 2 times the quantity x minus 4. Okay, so they may ask you what domain restrictions can you apply to the original function. And if we do this, if we do it that way, we could say y equals 1/2 x minus 3 squared plus 4 such that x is less than or greater than or equal to 3. Has an inverse function, okay, and we'll say f of x equals. Okay, f of x equals. So we'll say f inverse of x then would equal 3 plus square root 2 times 4, or x minus 4. Or we could say f of x equals 1/2 x minus 3 quantity squared plus 4 such that x is less than or equal to 3, and then the inverse function would be 3 minus square root 2 times the quantity x minus 4. I hope that makes sense. Let me know if you need help.